Welcome to Geoscienceengineering. Today in this tutorial, I'm going to explain you about HyP3. This is one of the easiest technique from which you can submit the data to the on-demand in the Alaska ASF data search. So we select the area and then we select the polarization and then we select the type of the data like SLC or GRD, and then we'll start the search. The best thing is the uh, product which you are looking for. Say example, you want to do the time series, so you can directly select the particular area of interest, and then you can click on the S bus, and then you can match the pairs, so you'll automatically get all the pairs, and then you'll submit it to the Hype3, and the process interferograms will be sent back, so you can download that, and from there you can continue the processing with MintPy. So right now I am selecting one location called Mon. It's in Nagaland. Now we are selecting the um, pairs. Just note one thing. See here you see one, two, three, and four, five acquisitions, right? So you have to select the proper acquisition, and based on that you'll get the reference pairs. And the other most important thing is, when you are looking at the pairs, see here you have October 5th to 25th 2015, October 17 2015, again 17 and 29, 29 and 10, like that. But the problem is, some of the pairs are covering the other acquisition which is out of your area of interest. So you need to properly zoom into your location and see which particular area or which particular acquisition is covering your area of interest. Or what will happen, you will be ending up in downloading the unnecessary data which are beyond your area of interest. So you have to just make sure out of this, because I have right now 291 scenes and they are 278 pairs. I've selected only the region where my area of interest belongs. So you also just have to focus on that one, and then you can write down, or you can just uh, zoom into the map, and then you can select the particular area. And after that, you have to go to the on demand, and then you need to select the um, InSAR gamma, and you will have to submit it. So here we are going for 10 into 2 looks. That means we will be getting a better quality of images. Here we are including the DEM, here we are including the inclination map, and then looks vector, and also the wrapped face, and also the displacement map. Generally what we do in Snap, we do everything manually, but in Hype3, what we can do is we can just select the pairs, and then if we submit the pairs to the on demand, then this data will be processed till the interferogram in the cloud, and then we will get the notification that this is done. Then we can download the data, and then afterwards doing the MintPy is more easier. So here there are MintPy options also. If it is enabled, it is okay, you can click and you can see the settings. If it is not working also, no problem, don't worry about that one. And we'll also have to make sure we are not selecting the apply water mask, because this is the one which is going to create a lot of problem when we are going for the MintPy processing. And I've submitted the data, I'm giving a name to it, and then I'll submit it. And after that I'll also show you how to download the data and do the whole processing. See here, when we are giving any project name, when you are downloading the data also, you have to check that project name, because you might have submitted some other products before, and that list will be still in the download list. So just to avoid the confusion, you have to give the name, and also you have to check whether that name or that data belongs to this name. Okay, now I have clicked the submitting, so it is getting submitted. And the other thing what I wanted to tell is, as we are going for landslide studies, and also deformation studies. There are few parameters which are responsible for the landslides. It is not just about the time series all the time. So in the coming videos, I'll also go for soil moisture. That means using the SMAP, soil moisture active passive satellite data, which will give you the soil moisture and the root zone moisture, both the soil moisture on the surface and the root zone surface soil moisture root zone. So with this, what will happen is you will try to understand like what is the soil moisture during before the landslide happened. Is that a cause of landslide? And also you can go for other options also, like you can go for the land use land cover. You can go for rainfall using ERFI. So I'll also show you the satellite data processing with the ERFI, so that it's a simple process. So we just download the data for a particular region, and I'll explain you what is SMAP and what is ERFI and how to extract the data and how the data is useful for the landscape analysis. You can also check for subsidence. See now, I'm just clearing this part because I already have 1452 products, but those are not the products which I have requested. And if you want to download, you can just go to the data download. From there, you can get the Python script, and that Python script you can run it into your Linux or in your PowerShell or in your CMD, so the data will automatically download into your directory. So these are the options what you have. You have the CSV, you have the JSON, you have the KML. This is just to make the inventory. Now I'm just clearing my things. I'm just logging in again. And here what will happen when I have logged in again, I'll see the data set, and then I just have to refine which are the expired projects and which are the existing products. So here I'm just logging in, and then we'll see the progress. So I've gone to this on demand, and I have 1263 projects and increasing 1452. That is because, like I told you, there are few past data also. If you can see here on the right hand side, you can see the project name is Mon Time Series. That means these products belong to the Mon Time Series. But there are other products also which belong to the other project. So we just have to look at the data which we got first, and then we will filter the expired data, and then we'll download only the data which is required for us. So this is how the output data from the InSAR gamma SLC, and these data sets will be expired within 11 days. So you have to download and keep them with you, or you cannot re-download again after 11 because it shows expired data. Maybe you can check that. I haven't tried that anytime. So here if you see, I have the interferogram, and then I have the project name, and like the things which I've added, looks is 10 into 2, phase filtering, and it will show you all the details which you have entered when you are doing the submission. So I have kept apply water mask as false, and the loss displacement is false, and then wrap phase is true. So for few cases, I am intentionally leaving the gap like that, so you can understand what kind of error comes when you are missing particular step. So in this the downloading part is the easiest one. You can just download, and after that we will just prepare the MintPy sheet or the configuration application, in which you will be downloading the you'll start the processing. So here I'm going to the view, and you can see some of them are failed and some of them are expired also. So these are the total files. Now I can just go to the data download and then download the Python script, and after that I can run that script and it will download the data automatically. So here is the location which I have downloaded. And remember, the place where you are keeping your Python file is the same place where the data gets downloaded. So you have to make sure it is in your project file. So this is my directory, the HyP3 folder, and in that I have kept this Python file, and I am running the script. You have to give your username and password, and this is your Alaska ASF password, not the Copernicus. Once this is done, it will successfully access the portal and it will start downloading the data. So I've downloaded all the data, and I'm just checking the files. So you can open the folder and then you can see the number of files. Now I have created one folder called extracted. That is because we need to extract the zip files into a particular folder so that the SBAS configuration, the small baseline app configuration will find out the required documents from that extracted folder, and then we have to go for the processing. So we are using the unzip command, because if it is 10 or 15 files, you can go for the manual extraction, but it is very huge. So you have to go for the terminal run. And most importantly, depending on your data, the processing will also take a lot of time, or the extraction will take a lot of time. So please make sure you are having the proper DEM, proper speed, and proper internet connectivity. So now I've given the command and the extraction is started. So here you can see the files are slowly extracting, and it will, like I told you, it will take a lot of time for the extraction. So I've selected this, the extraction is completed. Now I'm just going to the folders just to show you, because you need to be very familiar with what kind of data is needed. I've been processing this from many times, so I know which places to find out, but you just have to look at it once. So you go to the extracted file. I wanted to clear these files because it consumes a lot of space. Anyways, these files are already extracted, so I can just count first, and then I'll see the number of files that are available and number of files that are extracted, so that I'm just making sure that the same files are available in both the places. So I have 268. So in the same way, you can use the terminal, and then you can also count the files. So unless extracted, that is head, and then you'll see the simple file names. Now we need to count how many files are there. So I'm just going for one more command. It's find extracted max depth. It is 268. So in the extracted I have 268, and the raw files also I have 268. That means I'm having everything. And then in that I have to check the unwrapped phase. So unwrapped phase, it is 268. The same way I have to check the wrapped phases. I have to check the interferograms, and we need to check everything. So when we are going for a particular data processing, the small base configuration will ask for the DEM. It will ask for the unwrapped phase. It will ask for the interferogram. It will also ask for water mask, which you will be seeing in further. So we just have to make ourselves familiar with the paths, and those paths we are adding into the small base configuration application. And after that, we will start the MintPy processing. You can even check a single folder, like what it contains, because like I told you, there are two ways. One, you can go for the physical way and then you can check, or you can use the command, and then you can go to the particular folder, and then you can see the uh, data inside it. So I'm just taking a sample of one folder, and then I'm checking it. So these are the files what I have. I have unwrapped phases, I have water wrapped phases, I have the KML file. And the most important thing is when you have the KML file, you can also just open that KML and Google it and see whether the KMZ file, whether the downloaded data is exactly sitting on your area of interest or not. Because out of 200 or 300, only 5 or 6 data sets may go out of wrong. So you just have to look at that one once. Now I have activated the InSAR environment in which I have the small baseline app. So it is here at this location. Now I have to modify that small baseline app according to the data that is available. Based on that only, when we are running the steps, it will automatically get the information and it will start the processing. And most important thing, I'm just leaving it like this intentionally so that you'll understand what kind of error will come and what is the solution for that one. So this is my working directory, and now I have to um, create one folder. So whatever processing I am doing, it will go into that MintPy mon. If you want, you can delete all those the zip files which are downloaded, or you can keep the backup just in case if you don't need, or if your storage is so less. So we are going into the directory of MintPy mon, and from there we have to start the whole processing part. I'm just looking for the small baseline app. So I'm typing that home money mini forge, the location of my small baseline app, and then I am also going for the help. Minus H is help, so that it will tell you what information we have. If there is an error, it will show you. So we are first going for the loading of the data. That's the first step. That means we are telling MintPy the small baseline app configuration to load the data for the processing. See, I have these uh, scripts in which I have interferogram inversion, I have area, I have fringes, I have gamma, I have GMTSR, I have HyP3. These are all installed in my environment. So just to show you, I can go to the my Ubuntu and then home, and then in that if you go for the mini forge, because the location, so you go for the mini forge and then you go for the ends environments and insert and then bin, and here the whole list will be there. You just have to search for it. It's not necessary, but just making sure that whether those are available or not. There are so many files, so you can just go to the search bar and then you can also type the name in that, so you'll get the clear idea of what you are looking for. I'm looking for the HyP3 program preparation. See the location, it's in the location, and it is here. Now I have asked for the prep HyP3, but it is asking for minus h, that is the usage. So you have to type that one, the minus h. That means it's a help which will show you the usage of for what you are using that script for. So this is the helpline. Mm, so you have unwrap phase, dem clip, and then core file. And it is also asking for before loading you need these three files, so you have to very careful about selecting those files. Now I simply run that script without adding anything, so I got this error. When you have this kind of error, you have to be very, like, make sure what is needs to be done. So we are again checking for that file and the error also. Here it is mentioning after running the prep HyP3, you need for each interferogram you need the unwrap phase clip, core file, and the text. For the input geometry you need the dem clip or the dem file, and then you have to understand. See, now I have asked for the TIFF files, so uh, I'm giving the location also of the TIFF files. That means it contains all the unwrapped TIFF everything. So right now I have zero files because I haven't opened it properly in the folder. So I need to go and then reassign again. So I give the name again and I ask for .h5 also and the VRT and the name. So we are trying to find the required files. There are two ways. One, you can directly go to the location and then you can add the details in this from the windows, or you can use the script. This will be much easier. It will make your work convenient. So we are preparing the files. For each file it is generating the um, IFG meta. So I have searched for this, and then I have the unwrap page, and then I have the core TIFF. So I have all the required TIFF files under RSC. So I need to search as RSC, and then I'll get the list of datasets that are available for my processing, which I have downloaded from the Alaska ASF on demand. Now we are going for the preparation of HyP3. See, few steps will take a lot of time, but you just have to be patient. It doesn't mean it is not running, because all the raw processing which has to be done is already done. Now I am looking for the TIFFs. So there are 546 TIFFs in the whole extracted folders. Out of that, I am checking for the unwrapped phases. It is 268, and then core tips are also 268. So like that, I'm just making sure whether each folder is having the required data or anything is missing. So I have 268 data folders. So from that I got 268 um, unwrap phases. I have core files. Like that I have to mention, check where are those files. Based on that, we will have to configure the small based on application also. Here I have a problem with the create template. So I'm just re-entering that again. So here is the total details, which is showing you the create template also. So we are modifying the small baseline application now for the processing to start. See, this is how it looks like. So we are processing on HyP3. So we have to give the proper commands so that the script will only work for the HyP3 data. So when you are going down, you can see ISE to interferogram, geometry, and then multi-looking, modify the network. If you want to search, you can just click Control W, and then you can type whatever you want and then just enter. Then it will directly navigate you that particular term. So I'm searching for MintPy load processor. Here, if you can see, there are many uh, methods: ISE, ARIA, HyP3, GMT-SAR, SNAP, Gamma, Proipac, NISAR. So here we need to give the configuration so that it will only process using the HyP3. So here we are renaming to HyP3, and then we also need to add the unwrap file, the core file, the unwrap azimuth offset, range offset. I'll also tell you, I'm leaving some steps as it is without changing so that you'll understand which error will give you what kind of message and what to do with that. So this unwrap file, we have already looked it in the extracted folder. So you have that unwrap file tip files. So we just give that name. We don't give the folder name, we just give the path so that the script will understand and it will look for only the unwrap file tips. So it will check every folder and it will give you the final output. I'm just showing you also once. So in the extracted, if you go for this one, you have different tips. The unwrap phase, the DEM, the loss displacement, the core tip, everything. So based on this location, you have to give the same name to your configuration file. So I gave two locations, and now I'm back. Control O, Control X, O and enter. Control X, O and enter. Control O, enter and X. Now we are asking the MintPy to load the data. This is the first step. Do step load data, and after that you have the modify network, you have the reference point, you have the quick, or you have the correct unwrap error. So all the steps are already loaded in that. We just have to run that step. Now here I'm doing the first step, asking to load the data. Now I've left some options on it as it is. So you'll find few errors, and I'll explain you what to do when you find that kind of error. So here if you see no data files found, the unwrap phase, keep loading for the ionospheric stack. That means there is an error. The error is it is showing me in the bottom file not found error. That means there is a particular file which is not found. So the processing got stopped. The loading of data stopped. Now I wanted to see the configuration which I have loaded. And from there, I can see what is the error and what should be the solution. See here, if you see, uh, the MintPy load file is auto, and then I haven't given any name. The unwrap file we gave, the core file we gave, and we haven't given any path for the depth or the inclination angle, azimuth angle. So it will repeatedly ask you for different data sets. So you will understand one after the other in steps. So I again went for the nano, and then I'm editing. So here I have added the dem file, the total path, and now I'm going for the inclination angle. I'll also change that path like this. So it is in extracted, the folder name, and then it's a TIFF file. So that is how it will collect the information while doing the processing. So after the correction, I am running the first step again, that is load data. Now you can see it is finished writing, and the processing is complete because the required files are found. Now we will go for the next step, but there it is showing no lookup table latitude or range, but we will see that error in the next step. So in the MintPy folder only everything is created. And we are going for the next command, that is just change that do step to mod. It is modify the network. Once the required paths are given to that one, it will automatically do the whole processing, and it will tell you go for the next step. So the remaining step is reference point, quick overview, correct the unwrap error, invert network, and the correct LOD, correct offset, correct set, and all. So this will take some time. It's done. Now we just have to go for the third step. So this is very important. You need to check the data that is in your working folder, and also you just have to check the configuration like number of interferograms, hash keep, drop, and also the baseline information and the perpendicular baseline information. This is already we have given this when we are selecting data for the first time in the Alaska. Now we are asking for the reference point, so it will start looking for a reference date. So it will take some time to look for the particular file, and then it will give us the reference point also. So this step is also done, and then input data you have, and then it is selecting the reference latitude and longitude. After this we have to go for the next step. So you need to just record these well points, and then we go for the next step, that is correcting the unwrap files. So there are no errors, so this is successfully done. And next, invert network. Here is the step in which you will find lot of confusion, because it will ask for the latitude longitude, so you have to give the reference latitude longitude. See, here is the problem, because while running this I have some error, so we need to check into that, because input step is not found, that is invert network is not found. So we just have to look again, and then when you go for the running again of this step, then you'll see sometimes the typing error also will create a problem. See, again I had one issue, that is um, the interferogram inversion. So we need to go to the nano, and then we need to give the particular correction, then only it will clear this step, and you cannot skip the steps. Here I'm just checking for the interferogram details, but it is taking a lot of time, so I'll give you one more instruction. So you can just stop it and then go for only the head of the unwrapping phase. In this you can see mostly it contains zeros, and then I am going for the watermarks, because Like I told you, water mask is the one which is creating so much of problem. So we are skipping that part in the processing. But HyP3 script or the small base configuration doesn't know about the option we have disabled. So it will wait for that water mask. So we need to delete any existing water mask, and then we have to run the network inversion again. If that is also creating a problem, then we have to go into the configuration, and then we need to disable the watermark option, water mask option, so that the script will ignore that particular water mask thing. So here I got the same issue again. Now I have to go through the configuration, and then I need to edit that particular part. So I'm here at this water mask file, and it took the location, but we don't want that. So we are keeping, we are just making it as no. That means we are telling not to worry about that one. And now if we run the invert network again, it will run successfully. And there is one more option which you want to see. If it is giving an error, instead of giving no, you need to make it as none, because the script will read sometimes its own particular words like none, all those things. So you just go for the none option, and then you save, and then you run it again, then you will find the difference. So in the modify network also, I'm just telling not to worry about the water mask. So here you have that. So it is in auto right now. We just need to say no. So you run again. So if you see, the processing is running without any errors. So the step is completed. Uh, we didn't have any errors now. Took 24 minutes, and it depends on your system configuration also. Then we can go for the next step. So you can see the number of reliable pixels are 4025131, and we are going for the next step of correcting the um, we are going for the troposphere correction. See, there is a problem with the ERA5 also sometimes, because when you are going for the tropospheric correction, it will ask for the ERA5 data. That means the rainfall hydrostatic data, the wet and dry delays. If you are able to run, it is fine. Or you can download some data, and then you can put it in your working directory. Mm. From there, it will automatically recognize the data formats, and it will continue the processing. So that is why I'm going to give some detailed tutorials on SMAP and ERA5 also. So you can see the data is being downloaded for different things: geopotential, temperature, specific humidity, and then with the years and months, pressure level, everything. These are coming for your ERA5 for the products which you have downloaded. There are some products which you find very difficult for the ERA5. See, now I have a problem here. Now I just need to clear that. So I'll go to the nano ones to edit the configuration file. And then I have to search for the tropospheric. Here you see ERA5 from ECMWF. It is already there. So I need to tell the script to skip if this kind of error comes again. So I'm just giving a no, and then I'm saving it. And if I run it again, then the script will run. But if you haven't deleted few of the residual files, it will create a problem. If it is not creating any problem, then it is fine. Or you have to delete the HY files which are already created. So now current the tropospheric is done. Now we have to go for the DRAM. So just change that do step, and then go for the DRAM. It's done. And then correct the topography. See, it has created some HY files already. But when you find the error, you have to make sure in which location they are available. So you go through this sources also. MintPy, Mon, time series, residual H5, and Demer H5, all those things, because these are more needed when you are going for the total processing. It's a 22 step processing patch. So here, so it's all done 22, and then I got the H5 files, residual, time series, residual, time series, Demer, and then geometry, geo H5. Then we have to go for the next step. So you can try it in your area of interest, and then you can share your feedback also. If you find any kind of error, please let me know in the comments so that I can give you a solution for that one. If the data processing is taking more than 2 days, depending on the size of your data, then you have to check the processing whether it is going on fine or not. If it is going in within 2 days, and it will be okay, because when we go for the normal ISE2 and MintPy, it will take so many days just to run the first step. It doesn't mean you have to stop it. So have some patience, and then let the work be done. If you have any issue, you just mention me in the comment. I'll give you a solution. And now we are going for the next step, that is residual. So in the residual RMS also, it will take some time. And it is looking at the time series residual ram.hy, and the processing is done here. And after that, we'll go for the next step, reference date. And then after, we have velocity, geocode, Google Earth, and HDFEOS 5. Now the input reference date it took is 2021 January 18th out of all the data. So it is doing in 6 patches. So this is done. Now we can go for the next step also. We are going for the next step of velocity. And see, I have an error now. So I just have to be very careful and look what is the problem. That is because I have typed it wrong. And also there is a problem which I'll explain you, because I typed it VELEOCATY. So that's spelling mistake. That is why it happened. So if I type velocity again, now the processing is correct, and the dates from the files are 75, and then I'm creating this velocity HY files, and the processing is done, and we got the velocity file also. So we'll get one more error, but I am not going to explain you now. You can see by yourself. There are two files. One is velocity file, and the other one is velocity ERA file. So we are going for the geocode, because if this kind of error comes, it's not just in MintPy, HyP3, but there are few cases in which you'll get this kind of error in everywhere, every processing. So you just have to make sure what files are located in your path and what is the error that is giving to you. Now, I'm going for this velocity data PNG. Now that is also done for the Googler. Now I got that KMZ file, and then I have the image, and then I just have to look at the velocity H file and the first X step, Y step, and then X first, Y first. Now I'm using one script to extract this data, that I'll also upload it in the comment box. So if you want, you can use that, and then you can download the uh, extracted information from a particular location. Here I took one site and I got the location name, and when I click on that, I'll have the radius which I have given and the points, and you'll get the latitude, longitude, and the latest displacement, and you'll also get one Excel sheet with the mean displacement. This script I'm using it for myself, so I'll give it to you in the comment box and the description. You can download, and after that you can use it for your particular data. So this is how you are going to do the processing of HyP3 time series. Please do let me know if you have any other comments or any information you need. So these zeros also, uh, when you are doing the processing, you should see which areas are exactly in your area of interest. When I have downloaded, there are few places which are out of my point of interest. They are covering, but they are in the other acquisition. So these three files have created a problem. So I'm deleting those, and then I'll get the result. Sometimes you just have to continue the processing again to see the zeros are mentioning that these are not in my area of interest. So this is my script. So I'm just making small modification for this one so that I can get proper information. And it is up to you. If you want to use the script, you can use the script, or you can just leave it like that, no problem. And you can follow your own methodology. Now if you see, I've corrected. So I've removed those zero data sets, and now I got everything clear. And the time is also on the top here, 2017 515, like that, in the KML file. It is just filtering the unwanted zeros. Even if you don't delete, then it is no problem. The repeated data later you can see, and just based on these red, you can say about the displacement and the distances from the center point. But you have to do your own analysis from the site also. That is very important. In coming days, if I go to a site, I'll also try to make video on that. How do you do the ERT survey? How do you do the landside investigation and all? So please do subscribe and share so that it will be useful to the other people.